Welcome back to Fun Calculus. In this video we're going to look at the fun chart and also some of its applications to graphs. Okay, so looking back, right, fun chart, F-U-N, and then F prime, F double prime, increasing, decreasing, plus, minus, increasing, decreasing, plus, minus. You'll get really good at writing that lots of times because you'll use it so many times you won't be able to have fun anymore. Or, yes you will, because it's calculus. Anyway, so the first thing to look at is we're going to look at this relationship here in a little bit more detail. Let's say that over the course of the function, f changes from increasing to decreasing. Okay, or in the f prime world, f prime changes from positive to negative. Well, if you have a graph of f, and f changes from increasing to decreasing, that means you have like a hill, okay, or a peak, or whatever you want to call it. In calculus land, we're going to call this a relative maximum. And a relative maximum occurs when, okay, you can look at two things. Either f changes from increasing to decreasing, or if you're looking at f prime changes from positive to negative. And it does have to be in that order. It has to go from positive to negative. I would also like to note, and this is very important, this relative maximum occurs on the graph of f. Occurs on graph of f. So, if f prime changes from positive to negative, the graph of f, regular f, not f prime, would have a relative max. Okay, back to the fun chart. Or like the little version that we were looking at. Okay, let's go the other way. Let's say f changes from decreasing to increasing, or f prime changes from negative to positive. Okay, this is a little bit weird because the fun chart is set up like, not, I guess, backwards of this. If f goes decreasing and then increasing, then we have ourselves a valley, or a dip, or a relative, this is the technical word, a relative minimum. And so we can say that a relative minimum occurs. Relative minimum occurs on the graph of f, on graph of f, when, and then two things. Either f changes from decreasing to increasing, or if f prime changes from negative to positive. So it does matter the order. You do need to look at which way f prime is changing if you have a graph of f prime, but we'll look at some examples. Alright, the next thing to look at is the other half of the fun chart. F prime, F double prime, concave up, concave down, increasing, decreasing, plus, minus. Okay, this next one is kind of nice because it happens either way, any time any of these things sort of change. So, if f changes from concave up to concave down, that would look something like this. Either concave up to concave down. You can kind of see this part of the graph is concave up, and this part of the first part of the graph is concave down because it's sad, and the second part of the graph is concave up because it's happy, and over here, right in the middle, you have a place where it changes. The graph actually changes concavity. This place where the graph changes concavity is called a point of inflection. And just like I said earlier, this can happen both ways. So you could either have a change from concave up to concave down, or concave up to concave down. And so this would also be right there. That would be a point of inflection. Happy, concave up, sad, concave down, and your point of inflection would be right in the middle where it changes. So just like there were two ways to tell whether or not you had a relative min or a relative max, for points of inflection, there are three. So point of inflection occurs, and again this is on the graph of f, when, okay, so the first one is if the graph itself changes from concave down to concave up or vice versa. So f changes from concave up to concave down or vice versa. It is important to have the vice versa because that implies that it could happen either way, which it can. So you need to make sure that you say that to demonstrate that you understand that it could happen either way. Similarly, this is f prime. So f prime, in order for f to have a point of inflection, f prime would have to change from increasing to decreasing or vice versa. Increasing to decreasing or vice versa. And then the last one is, of course, f double prime, and that would be, actually we'll do that in green. This would be f double prime changes from positive to negative or vice versa. Changes from positive to negative or vice versa. There we go. So basically, based on the graph that you have and the information that you want to get from the graph, you will use different combinations of these phrases in order to justify your answer. Let's take a look at some examples. Let's say this is the graph of f, and you want to know everything about the graph in terms of relative minimums, relative maximums, points of inflection, increasing, decreasing, concave up, concave down, etc. So, if you have the graph of f, this is actually the easiest one because you just sort of look at it and you tell, right? So, right here-ish, let's say that's at 0, f, so you'd say f has a relative max, you can abbreviate that rel max, and you do have to say where it is, x equals 0, because f changes from, now this is where the fun chart comes in handy, right? You identified that f has a relative maximum, you identified where it has a relative maximum, and now you need to justify. Your justification comes straight from the fun chart. Here's your fun chart, you'd be like, oh, right? If f has a relative maximum, remember that's this relationship here, and your justification needs to use the graph that you're given. If you're given the graph of f, all you say is that f changes from increasing to decreasing. That's what we have. That's what we're going to say. So f has a relative max of x equals 0 because f prime changes from increasing to decreasing. Hooray! Next we're going to see where f is increasing or decreasing. Notice that f is increasing along here. And when we write increasing, we're going to use interval notation. That's going to be the most useful and quickest way to write things. So we're going to say f is increasing on the interval. This x value way out there is negative infinity. And we stop increasing at 0. And these intervals will always be open for a reason that I'll explain in class, because it's complicated, but not really. Just, they're always open. It's okay. Don't even think about it. And then f is decreasing down here, and so you'd say f is decreasing on the interval from 0 to positive infinity. So we start at 0, we go all the way along there, and as we do that, f continues to decrease and go down. A couple things. First of all, we didn't need to justify that f was increasing or decreasing because we have the graph of f, and you can just look at the graph and say, oh yeah, it's increasing, and oh yeah, it's decreasing. The second thing is that when you read graphs, you always go from left to right. Some people will say, oh yeah, it's decreasing because it's going down, but you read it backwards. You're a mountain climber, and you always go from right to left, and you got to climb up that mountain, it's increasing, and then you got to say, oh yeah, I got to go down the mountain, now it's decreasing. So it's just like reading. Go from left to right, and you'll be fine. The last thing for this graph is that, oh yeah, look at that shape. That shape is always concave down, and so we say f is concave down on the entire interval from negative infinity to positive infinity. Again, no justification because we have the graph of f, and you can look at it. Alright, you guys ready? It's going to get fun. Get it? Okay. Hey, let's say you have a graph, and this is your graph. And now this is the graph of f prime. Ooh, game changer. Okay, and here are some values. Okay, and you want to know stuff about, right? We care about the graph of f. Okay, graph of f. So, given f prime, we don't know what the graph of f looks like, but we can use logic and reasoning and the fun chart to figure out stuff. The best thing to do first is figure out where f prime crosses the x-axis, if at all. Notice that f prime crosses here and here, and what I like to do is I like to label f prime as being positive or negative in these regions. Here, f prime is negative. Here, f prime is positive because the y values are all positive. And then here, f prime goes back to being negative. So check it out. This is kind of cool. So over here, at x equals -2, notice that f prime changes value, right? It changes from negative to positive. Oh, there's something on the fun chart about that. Let's go check it out. Here's the fun chart. F prime changed from negative to positive. That means that the graph of f had to change from decreasing to increasing. And we had a word for if the graph of f changed from decreasing to increasing, and it was a relative minimum. Therefore, we can conclude that f has a relative minimum at x equals -2 because, now for your because reason, you have to reference the graph that you were given. We were given f prime, so we're going to say because f prime changed from negative to positive. Just like that. Now we're going to keep going and we're going to look at the other place where f prime crossed the x-axis. That's over here, and that's going to be x equals +2. And notice that x equals +2, f prime changes again. F prime changes here from positive to negative. And if you know I'm going to the fun chart, guess what? We're going to the fun chart. Alright, so here, f prime changed from positive to negative, which means that the graph of f had to change from increasing to decreasing. This is a relative maximum. So we write our sentence. F has a relative maximum at x equals +2 because f prime changed from positive to negative. Hooray! Another quick way to see this relationship is to actually write in what f is doing in each of these intervals. So for example, right, -2 is a break, and, whoa, not there, +2 is a break, and so when f prime was negative, f, right, so this purple stuff is f is decreasing, and then between the two, f is increasing, and then afterwards f is decreasing. So you can kind of see that, oh yeah, we're going to have a relative min there, and a relative max there. That's another way to see it, but I like the fun chart way too. It's the same thing. Okay, same graph. Next we're going to look at, does the graph of f have any points of inflection? Well, to do that on a graph of f prime, let's go to the fun chart. For the graph of f to have a point of inflection, we're going to look at this first column of relationships, and notice that if we have the graph of f prime, we're going to see if f prime changes from increasing to decreasing or vice versa. If it does, then we know that the graph of f has a point of inflection because f changed from concave up to concave down, even though we didn't see it. So, here's our graph of f prime. Does f prime change from increasing to decreasing? You bet it does. Here, f prime is increasing, and here, f prime is decreasing. Therefore, here at 0, f has a point of inflection. So we're going to say f has a point of inflection at x equals 0 because, and the reason is, f prime changes from increasing to decreasing. Notice here we don't have to say the vice versa specifically for this particular instance because f prime does change from increasing to decreasing. There's no vice versa, it's just increasing to decreasing. Now, if you were to justify multiple points, like if x is 0 and 7 and -2, and you had different combinations of increasing, decreasing, then you could say, or vice versa at the end. As a general thing, if you want to be safe, you can just say it, but sometimes it's nice to just be specific for each individual point. It's up to you. But again, if you're not sure, just add the vice versa and no harm, no foul. On this graph, we can also tell where the graph of f is concave up or concave down based on f prime being increasing or decreasing. Notice again this blue part, f prime is increasing. So on this blue part, f is concave up because f prime is increasing. And that comes directly from the fun chart as well, over here, right? If f prime is increasing, which it was, f has to be concave up. Similarly, if f prime is decreasing, therefore f has to be concave down, so we can say f is concave down, and I'm going to add the interval here. It's 0 to positive infinity, because f prime is decreasing. And so here we can add concave up on negative infinity to 0. So there we go. Last one. Okay, same shape of the graph, but now we're going to look at f double prime, that's a double prime, and see what happens. So notice with all these that even though we had the same shape of the graph itself, this changed what happened on the actual graph of f. So because this is f double prime, all these points are going to mean different things. Okay, on f double prime, there's really not a lot we can do. We can tell, and that's because the fun chart, right, f un f prime plus minus f double prime, sorry, I messed up the fun chart, which is not good, increasing, decreasing, f prime plus minus. The only thing we can tell on a graph of f double prime is, well, if stuff changes sign, then f is going to do stuff. So we're going to look on the graph of f double prime. Okay, where does f double prime change sign? Changes signs here and here. Over here f double prime is negative, here it's positive, and down here it's negative. And so we could do, oh yeah, there's a switch, right? F prime is changing from negative to positive, so we can say that relationship meant a point of inflection on f. So we can write that. F has, and actually there's two of them, because f prime also changes from positive to negative here, and that's also going to be a point of inflection because we're going back and forth between these two. So f has points of inflection at x equals, and let's call these positive and negative 2 again, negative 2 and x equals 2, because f double prime changed from positive to negative, or vice versa. This is an excellent place for that vice versa. It's also okay to justify each one separately, so if you want to write two separate sentences, you can. Warning, never use it, because it could refer to anything, and if you say it, it means that I don't know what you're talking about, and you might not know what you're talking about, so please use not the word it, but be specific. If you're talking about the graph of f prime, say f prime. So inappropriate use, bad use, poor use of the word it would be like this. F has points of inflection at negative 2 and 2 because it changed from positive to negative or vice versa. This is bad because I don't know what it refers to. It could be the graph of f double prime. It could be the graph of f prime. It could be your mother. I don't know, so don't use it. Use the thing you're talking about. If you're talking about f double prime, say f double prime. Thanks, and have a great day.